So today we are going to go through your air masses and fronts notes together. You guys have a student version in your folder on Schoology for today. You'll want to either split screen your computer so that you have the video on one side and your notes on the other side. Or I know some of you guys have access to a laptop or computer you can use as well. So you can put one up there and have the other on your iPad to be filling out while we're doing this. To start you guys off, we're going to take a look at air masses. And all an air mass is a chunk of air that has the same properties. So it's the same temperature, same humidity, talking about how much water is in the air, and same density. There are 4 different types we're going to look at. All right. So you guys have this little graphic organizer to go through those 4 types of air masses. We can have this tropical continental, you can have tropical maritime, you can have polar continental, or you can have polar maritime. Okay, those are 4 different types. All right, so you guys will want to fill in this part to start. So what we're looking at here is this word right above your little boxes here. Continental means that air mass is forming over a continent. It's forming over land, okay? Marine or maritime tells you that air mass is forming over water. Usually we're talking about an ocean when we talk about this, or some large body of water. So maritime means ocean or water. So same thing over here on our polar side. If it's continental, it's going to start on land. Maritime, it's going to start on water. All right, second part. Looking at the meanings of these words and how do they apply to our air masses. So anytime you see tropical, we are talking about warm air. If you see polar, we're talking about cold air. Okay? Continental means it's going to be dry. If it's forming over land, since there's not as much water over land, that air is going to be drier. Whereas if it's forming over water in your maritime, it's going to be very wet. You're getting a lot of transfer between that water and the air. The air is going to hold that water that's getting transferred between the ocean. Okay, same thing over here then. Continental is going to be dry. Maritime is going to be wet. So what we're going to get from that in order to put in our boxes down here. Okay. Our tropical air is warm. Our continental air is dry. So it's warm, dry air for tropical continental. Our tropical air is warm, but our maritime air is wet. So if it's tropical maritime, you get warm, wet air. Because that air is so wet, it's holding a lot of water, right? So you're more likely to get precipitation. And being in a warm area, that precipitation is likely to be rain. Over in our polar side, so continental again is dry, but now it's cold air, being polar. Maritime is again wet, but now we have cold air. Because it's wet, we're going to get that precipitation again. But now that the air is colder, usually that precipitation is going to be snow. Sometimes it's still rain, but with that colder air, it's much more likely to snow. Okay, how can this be applied? So that's what this example that we're going to go over here is. So our question is, once air mass A reaches location B, the weather conditions at B will most likely become blank. So we are looking at this air mass right here. We want to know what the air was like where we're starting. Okay? At A, over the Gulf of Mexico, we are starting over water. So that air is going to be wet and humid. Because we're starting farther south, this is going to be considered tropical air. So it's going to be warm air, which means that our answer for this question is B. That air is going to be warm and humid. So it's forming right here and it's moving upward and it's going to bring warm, humid air up to here. Two more questions. So looking at the four labeled air masses, which air mass is a dry, I'm sorry, you can't see it underneath my head. Which air mass is a dry, cold air mass? So since it's dry, we're looking at a continental air mass. We're looking for something over land. And with it being cold, we want it to be farther north or closer to the pole, which means number 2 is our correct air mass. It's over land, it's over Canada, and it is close to the North Pole. For the second one here, what is the name of air mass number 1? So up in this top corner here, well, it's found over water, so it's considered a maritime air mass, and it's close to the pole, so this is a polar air mass. So our answer is maritime polar. Okay, moving on to fronts then. Fronts are when we have a warm air mass and a cold air mass, and they're colliding. Okay, I actually have this wrong on here. Great. And this should say a cold air mass and a warm air mass where they're meeting. So we have 3 different fronts that we're going to look at, and the names are going to correspond with the type of air that's moving in or the type of air that it's bringing into an area. And we'll have a symbol that you would be able to see on a weather map for each of these 3 types of fronts. And what the symbol does is it tells you both the type of front and it also tells you the direction it's moving. So for example, I have a front down here that I have a picture of. And you see that the little spikes here are on the southeast side. So that is pointing in the direction that this front is moving. So this front is moving this way. All right, 3 types of fronts. Warm fronts is our number 1. A warm front is going to bring warm air. So we're going to get warm weather. Sometimes you'll get rain that goes with it. A lot of times when we have weather changing or getting a new front coming in, we often get rain to go with it. Our symbol on a weather map is going to be red for warm. Warm is usually associated with red. And you're going to have these little half circles coming off of it. And those are going to tell us our direction again. So since the half circles are pointing northward in this case, this warm front would be moving to the north. Cold fronts are going to bring in cold air. You get a lot of rain with a cold front coming in, a lot of severe weather. This is usually when we get the most snow and the most thunderstorms. The symbol that we're looking at for this guy is this blue symbol with triangles. And those triangles are telling us which direction it's moving. So this cold front is moving southward, bringing in cold air. Here's where the cold air is. As it moves southward, it's bringing that with it. Third type is called a stationary front. So this one's a little bit different in that we have both a warm front and a cold front that are pushing against each other. So they are fighting to take over, but neither one is winning. So what happens is we get the same weather for a long period of time, usually a couple days straight. A lot of times you get a little bit of rain with this. It's usually fairly warm weather that comes. And looking at our little symbol down here, you can see that opposing fronts. Our warm front is going northward here, and our cold front is moving southward. So then this line would be right where they're kind of meeting and competing against each other. Okay, taking a look at how this actually affects weather then. So this is a little graph for you that we are going to be taking a look at these little red dots. Those are showing the weather and how weather is changing. So 3 questions that we're going to look at. When did the front arrive in this image? So we are looking for a time when we see our temperature changing. My temperature first starts to change right here, which looks to be about 1:30 in the afternoon. We start to see it warm up. So the temperature is increasing, which tells us that since we're getting warm weather coming in, a warm front moved in. It's bringing that warm air with it. Second example, this one's kind of showing the opposite. We're looking at pink dots here. Our front arrived when our weather started to change. We saw a decrease starting at 2 o'clock, okay, and that temperature was dropping rapidly, which means that we had a cold front coming in. It was bringing cold air in behind it or with it. Okay, last part for you guys. I just wanted to do a quick review on your pressure systems because you're going to see them in your assignment for today. So on a weather map, we use H and L as your symbols for pressure systems. We're going to use a blue H and a red L. If you remember, high pressure is associated with cold air. Cold air is denser. Those particles are much closer together, shown here. And because they're denser, it's going to actually sink. So we have cold air sinking in a high pressure system. And this actually leads to really nice weather. We get really sunny weather outside. Whereas in a low pressure system, we're using red because we have warm air. Warm air is less dense. Those particles are farther apart. So it's going to rise up over colder air. So we have warm air rising in this case. Warm air has a tendency to hold water. So we actually see all of that water that's held in that air is going to condense. It's going to cool off the higher up you go, and it's going to condense and turn into a cloud. So this is when we're going to see lots of cloudy, rainy weather, is when we have that low pressure system. All right, that is all I have for you guys today. Good luck on your assignment. Let me know what questions you guys have as you go. You're doing awesome. Keep doing what you're doing, and have a wonderful day, guys. Bye.